Okay, Bismillah ar-Rahman ar-Rahim. Alhamdulillah, we start today the new chapter. It is called the system of linear algebraic equation. That means the easy one, this topic, because difficult topic we already finished is a non-linear. Non-linear always difficult. Linear is a very simple topic we have here now. We have but this is one of the best topic also from any research point of view, because if any research is going on, they convert their research in the form of the system of linear equation and solve their system with the help of numerical method and find the solution here. So that's the things we will use. And what is linear equation? As I say, the all unknown we have on the left hand side must have a 1 power 1. So that's a simple case we have here now. the power of the unknown variable should be 1, then we call it a linear equation here. And like this one, but one thing to remember also here, this is a 3 variable. If you really look at this one here, this is a 3 variable. Power is 1. But the problem is what? 2 variables come together. That's we don't want. We say each term of an equation must have 1 variable and its power of the variable should be 1. Then we call it a linear equation. This is a simple definition of the linear equation. And we know what is the graph of the linear equation. The graph of the linear equation always is a straight line we have here. And the simplest linear equation we have is a linear equation of 1 variable. Linear equation of 1 variable. This is the linear equation of 1 variable, and we can easily find the jawab of solution of this problem. What is the solution? X is equal to b over a. And when we put b, why we call this is a solution? Because when we put in place of x b over a, you have the right hand side same. So alhamdulillah, we call this is the solution of the linear equation we have. This is, I give the linear equation of 2 variable, Of course, with a1 and a2 and b are some coefficient. And that coefficient will be any number, maybe any real number, maybe negative, maybe positive, maybe 0. For example, particular case we can have here now. This is linear equation of 2 variable, linear equation of 2 variable, and this one. But one thing to remember that one here, as you increase the unknown variable in the linear equation, your linear equation becomes slightly difficult. You can have same like this one, linear equation of 3 variable, which have a 3 variable. And 4 variable 5. So as you increase the number of variable in the linear equation, your linear equation become difficult to handle here. This is, I give you the linear equation of n variable, x1, x2 up to xn equal to right hand side b, where a1, a2 and an and b are the any real number we given, and the only things we have to find out the x1, x2 and xn. And when we find the value of x1, x2 and xn, we put back into this equation and we have the right hand side same, then we can call it is the solution of the linear equation. But as I told you, as you increase the variable, unknown variable in the equation, your linear equation slightly become difficult to handle it. So to avoid this difficulty, what we do, we can, as we increase the variable, we also increase the equation. If you have a two variables, so we have a two equations. So when we increase a variable, we increase the equation also. This will solve our problem in some aspect. So when you increase the number of linear equation, then we call it a system of linear equation. So what is system of linear equation mean? The system of linear equation mean you are given finite set of linear equations. Finite mean you must know how many, 2, 3, 4, 5, 22 million here. So system mean you are given at a time more than one linear equation. We call is a system. For example, this is a system of linear equation because you have more than one equation. You have system of the linear equation. So what is our topic? Our topic is a system of linear equation. It means we must give the example, or we will discuss the example where you are given more than one equation we have here. Now, if you can see here in the linear system, two things are very, very important things that you must know. Number one, M, which we call number of equation, and the second one is N, which we call number of variable. Variable, when I will call variable, I mean unknown variable. So when you are given the system, you first things you have to check how many equation it is given here and how many variable is given here. For example, if you can see here, when we have this system, we have how many equation? Two equation. How many variable we have? 1 and 2, two variable. When we are given this system, how many equation we have? 1, 2, and 3. And how many variable we have? X1, X2, X3, and X4. So before you solve the system, you should know how many equation you have and how many unknown variable you have here now. This is generalized case for the system of linear equation. We are given M equation, 1, 2, 3, 4, and M equation. How many variable we are given? X1, X2, X3, and X. This is a generalized shape of the linear system we have here now. Now, as I told you, when you have the system, you should know the shape of the system is what type. That means you should know the type of the system. And we have generally the three type of the system, which we discuss here now, which satisfy this condition. Number one, M is greater than N. That means you are given more equation but less variable, or you are given less equation and more variable, because M represent equation and represent the unknown variable, or you are given M is equal to the N. Here, for example, here what you have, M equal to N. What you have here? Here you have N is greater than M, because N is 4 and M is 3. And here in generalized case, what you have? You have unknown variable are N and unknown M, and the number of equation we have M, and we don't know how many we have. This is given the system simplified form here. We write in the shortcut for this system in the form of this one. This and this one is a very shortcut we have here now. Now, of course, when you have do now what? We are given BI. We are given AIJ. The only things we have to do what? To find XJ. And if we find XJ and we say XJ equal to CJ, that means X1 equal to C1, X2 equal to C2, X3 equal to C3, and Xn equal to Cn. Then When we have this is the set of number, when we put back into the here and your left and the right side is same, then we call that, when we put, then we call all C1, C2, and Cn are the solution of the linear system, the solution of the linear system we have here. Now we have the three possible type, which I discussed with you before here now. The first type of the system, we have the case when m is greater than n. And the shape of this system is what? Is like this one. How many equations we have? 3. How many variable we are? 2. Doesn't matter. The coefficient of x2 is here 0. And the coefficient of x1 in the third equation is 0. So it doesn't matter, because I say the coefficient may be, the coefficient may be 0, or maybe negative number, maybe positive number. Now, when you have this shape of the system, you can have a general idea what possible solution I can get. Not exactly way, but some roughly you can have the idea of the solution of this type of the system before solving. This type of the system typically or generally mean most of the case, this type of system has no solution. This type of system has no solution. What do you mean by no solution? No solution mean after finding the value of unknown variable, you put back into the system, your left and the right is not satisfied, then we can say no solution. This I give you a very simple shape of the system. What is the solution for x1 and x2, please? Anyone?
x1 equal 2 and x2 equal 3.
Yes, x1 is equal to 2 and x2 equal to 3. When you put x1 is 2 here, x2 is 3 here, 2 means 6, 3 means 27, and 6 plus 27 is 33. 33 never equal to 13. This means this equation is not satisfied. If any equation of the system is not satisfied, you simply say that is a wrong solution. That means no solution we have here. Let's move to the second type of the system. But remember that first type of the system, when m is greater than n, we give the special name of that system is called overdetermined linear system. Now, the second type of the system behave opposite to the previous one. We have number of unknown variable is bigger than number of equation we have here now. And this type of system, we give the special name that is called the underdetermined system. And the shape is this one here. How many equation you have here? The 2 equation. And how many variable, unknown variable within the system are 3, x1, x2, and x3. Doesn't matter, x3 coefficient is here 0. The coefficient of x1 is 0. No problem for that. Now, in this case here, when we solve this type of the system, we have roughly idea. I'm not saying always, roughly idea we can say. If your system is underdetermined system, we satisfy this condition, then this type of the system generally have infinitely many solutions. Most of the case, infinitely many. Not always, but most of the case, they have infinitely number of solutions. Now, I can give you the answer for this. How can we have infinitely number of solutions? When we have this type of the system, when your number of equation is less than number of variable, we always assume one of the variable for such case by ourselves. We assume any variable, for example, x3. When we assume x3, we can have easily the value of x2. When we have the value of x2, we can have the value of x1. For example, as I say, I say, let assume x3 equal to 1. When x3 equal to 1, so what we have? 4 take on the other side is 17. Taqsim by 3, give you the value of x2. And then after having the value of x3 and x2, you put in the first equation, you can easily have the value of x1. This is a solution. But this solution is for what? When you assume x3 equal to 1. Let's say you not assume 3 equal to 1, you have x3 equal to 2. Then you have a new shape of the solution, which x1 and x2 are different than previous one. So it means it is this type of system is also depend over assuming choices. What we assume, what choice we take of the variable. If we assume x3 equal to 10, we assume 20. We can assume any number between minus infinity and infinity, but always assume the smallest number. Easy to calculation we have here, but no assume of the 0, please. So therefore, each time we assume we can have a different solution. That means you can have a infinitely many, the solution we have. Now we move to the third case now. And the third case is when m is equal to n. This type of system generally we call is a simultaneous system. And that's most problem and generally case we have here. The simultaneous system has a unique solution. A unique solution. A unique solution mean only the one. For example, I solve this system by using some method. I give this is a jawab. You use any, because we have many methods for solving the system. You use any method, you will exactly get the same jawab. When you got the jawab here and you say this is a unique solution, and you can satisfy by yourself putting that value of the variable in each equation and check right hand side and the left hand side exactly the same here, or very, very, very close each other, then we can say it is a unique solution of the linear system. So you can have the shape and you can have roughly idea of the solution. If your shape is overdetermined system, which means your number of equation bigger than number of variable, then you call that system is overdetermined linear system, and the such type of the linear system generally have no solution. Generally, I'm not saying always, please. And when you have a system n is bigger than n, then call that system as an underdetermined system. And generally, this type of the system has infinitely many solution. I told you how to we can infinitely many solution. And when you have this condition, m is equal to n, we call that system is a simultaneous system. And generally, this type of system has a unique solution. But please, again, I never said that the simultaneous system always have a unique solution. No, this is not true. But here we have a more chance to get the unique solution. So it's mean what we will do, inshallah, in chapter number 3, we will not discuss the system like this one or system like this one. Our system must be the simultaneous system. Why we consider simultaneous system? Simultaneous system, we can have a chance of the unique solution we have here. Or we can say the linear system has a unique solution if we have all equations are independent. They are not depend on each other. They are not depend on each other. Then we call is a equation are linearly independent, and linearly independent system always have a unique the solution we have here. Come to now. This means whatever I do now, the system mean the unique solution. The system is a simultaneous system, and therefore we look for the unique solution of the system. Yeah. So, but I told you, yeah, simultaneous system generally have a unique solution, but not always. It means generally the about the simultaneous system, what we say, every system, because I told you when I say system now in this chapter, I mean simultaneous system. Every simultaneous system of a linear equation may have no solution, may have exactly one solution, or may have infinitely many solutions. It means also no guarantee simultaneous system give you always unique solution. Must be satisfy this theorem we have here now. Now I give you the example. We have, this is a simultaneous system, simplest simultaneous system, 2 by 2 we have here now. And we know the graph of this, graph of this system, graph of linear equation is a straight line here. And if you can graph for this one, can you see when you graph the system, this one here, you have this shape, right? You have this shape of this one here, and you can see here, because this is 2x1 plus 2x2 equal to 1. This is 2x1 plus 2x2 is 3. So your left-hand side is the same for both, but the right-hand side is different. It means when you sketch the graph, they are not intersecting. And when they are not intersecting, what that mean? That means
No solution.
no solution we have here now. Let's take another example we have. We have another example, x1 plus x2 equal to 1. 2x1 plus 2x2 equal to 2. Can you tell me about the system, this one? Sorry, equation, linear equation is the difference of the linear equation or the same?
It's multiplied by 2.
Yeah, so it's the same. Is it dependent? And it means when you sketch the graph of this one, exactly the same graph. And same graph mean they are intersecting each other. And what does the intersecting mean? The solution. And how many solution we have for this case, please?
Infinity.
Infinitely many solution. And the third case, I choose this one here. When sketch the graph of this one, the intersection only one point, which is this one. And it's mean your system
Unique solution.
is a unique solution. It's mean if your system is simultaneous system does not give you guarantee always have a unique solution. Simultaneous system may give you no solution, may give you infinitely many solution, or may give you the unique solution we have here. But over which is always to have this case in our chapter number 3, the unique solution of the system. And when you can easily, when you sketch the graph here, you can easily find out this is a 2 and this one is 3 you can have here now. So solution is 2 and 3, and you can check by yourself. You put 2 here, 2 minus 3 equal to -1. 2 means 6 minus 3 equal to 3. Both left-hand side, both equation left-hand side and the right-hand side give you the same. It means it is a unique solution of the linear system we have here. Right, this is the things we have here now for the case of please. So now we are guaranteed now The simultaneous system may have one solution, may have no solution, may have an infinitely many solution, but we are always interested the unique solution. How? That's I will tell you later on. Now I give you the matrix form of the linear system. This is the matrix form of the system. How many equations you have now? 1, 2, and n. And how many variable unknown are what? X1, X2, and X. And it means the number of variable and number of equation are exactly the same. And this is our case because we consider only the simultaneous system in this chapter. And simultaneous system means the number of equation and number of variable must be the same here. We write in the matrix form we have here now. This is the matrix form we have here now. Is a, and we make them separate, the coefficient and the unknown variable. And when you multiply this one, exactly the same thing we have here. And these two matrices are equal. And then we can say the first equation is equal to first row equal to B1, second row is equal to B2. And can you give me, what is the size of this matrix now? Yes, anyone?
Size of the matrix?
Yeah, this is a matrix you have. What is the size of this matrix?
N.
Huh?
N into N.
Allahu Akbar. This is n by n. What is this one? N by 1. This is what? N by 1. What is this one? How many row we have for this case?
N.
How many column we have?
N.
Allahu Akbar. We have only one column because this is together. This is together. It is not like this one. This is not in the plus here.
Oh, okay.
So this is column is 1 because otherwise we cannot put here because what is the size of this one? N cross 1. Can we say the matrix size n cross n equal to n cross 1? No, this is not. Should be the same size we can have here now. Agree?
Yes.
So we have this one. We can separate them here like this one and this. That's I call it. This is my A. And what is A? I call A is a coefficient matrix, always given by the teacher. What is this one? This is my unknown matrix or column matrix. What does a column matrix mean? Column matrix mean many row but one column. That you have to find out. And what is this one?
Constant matrix.
Is the right hand side column matrix or matrix of the constant, because right hand side always a constant here. That we have here. You are given A, you are given B, and that X you have to find out here. So we can put in the shortcut of the chapter number 3. Shortcut of the chapter 3 is AX is equal to B. This is, what is the shortcut of chapter number 2, please? Any student? Shortcut of chapter number 2 was what? The shortcut of chapter 2 was f of x is equal to 0, the nonlinear equation. And the shortcut of the chapter number 3 is ax is equal to b. And I told you a given, b given, and x you have to find out. When a given, b given, x you have to find. If you have no condition on a and b, you always have x. In which sense? We have no guarantee. X may be no solution, maybe many solution, maybe unique solution. Because I told you the linear system, simultaneous linear system, having 3 choices of the solution: no solution, infinitely many solution, or the unique solution. So if we have a no condition, we put on A and B, we are blind and we can simply say, may have a no solution, may have a no solution, may have infinitely many solution. Now, what we do here now, we put the condition on, because your solution depend on A and B. We put the condition on A and B, then to have a guaranteed unique solution. And the condition on A and B is what? The condition on B is very simple. Condition of the B is that all your right-hand side not equal to 0. That means your B given maybe 1, 0, this is 0, but not all 0. That means to have a unique solution, the condition on B is that B should not be equal to 0. If this is a linear system, and in the linear system, if your B right-hand side is not 0, we always call that system as a non-homogeneous linear system. We always call non-homogeneous linear system. So to approach to the unique solution, first condition we put here is it should be non-homogeneous system. Now, the most difficult things in the chapter number 3 is the condition on A, and A must be non-singular. What is non-singular? I'll tell you later on. Non-singular. It means if your A is a non-singular and B is not equal to 0, then system must guarantee have a unique solution. It means to check, to find a unique solution, you have to check B and A. B should not be equal to 0, and A is non-singular. What does the non-singular mean? You already discussed in 107.
Invertible.
Yes, is invertible. If your A is invertible, invertible mean inverse must exist, or the determinant should not be equal to the 0. If the determinant is not equal to 0, which means is invertible, then we call it is a B not equal to 0, and A is a non-singular. What is non-singular mean? Determinant not equal to 0 or inverse must exist. Then you always have a unique the solution. Now, please, you have all the condition to approach to the unique solution. First one, you're having a system. What type of system you have, please? You have a linear system. You have a simultaneous system. So that's the condition, please. 4 conditions you have to remember, please, about the system. You are talking about the system in chapter number this. But what is your system should be, please? Should be linear. And you know what is the linear system mean? All the equation inside the system must be the linear one. Number 2, it should be what? It should be simultaneous system. Simultaneous system means the number of equation must be equal to the number of unknown variables. Number 3, what is the number 3? Your system should be what? Non-homogeneous. Your system should be non-homogeneous system. And what is the 4th one, please? Your system should be what? Non-singular. If we have this 4 condition with us, then it is 100% guarantee you have what?
Unique solution.
Unique solution we have. If condition 4 not satisfy. Not satisfy, then what happened? If the condition 4, which is non-singular, if it is not satisfied, what happened then?
It's have infinitely many solution or no solution.
Yes, if we have the condition 4 is not satisfied, we never have a unique solution. And when we have never unique solution, what that mean? We have either no or many solution. This point, please, you have to remember. Wallah, chapter number 3 is nothing. Only this condition you can have here. Is okay? Let's I give you a special matrix for that case here, which we call augmented matrix. We have augmented matrix is what? The combination of A and B, because when you solve the system, what you need, please? If you solve the system, you need what? You always need what? A and a B, because your X depend on A and B. So if we put together A and B, we have called the augmented matrix. Especially we use this matrix when we solve the linear system with the help of numerical methods. So we use that one here. So A and B, I put the line between them just only to differentiate between A and B. Left side of that line is your A and the right side is your B. That means if you have this is the augmented matrix, what is your last column? The last column should be always your right hand side. Maybe in exam I never put, or in the some example I never put the line between them. But when I call the augmented matrix, it's always mean that your right hand side is what? Sorry, the last column is what? Is your
right hand side.
The right hand side we have here. Can you give me anyone the size of this matrix, please? Let's see how good you are. What is the size of this matrix? How many rows we have, please?
N rows.
Yes. How many columns we have?
n+1.
N+1, because this give you the n row, n column. One column, first column, second column, third, fourth, n column. We extra make one column now because B is here the column matrix. So the size of augmented matrix always is what? N cross n+1 we have here. That's the things I put it there in the augmented matrix form. How can you put in the augmented matrix form? 1, 4, 7, 2, 5, 8, 3, 6, 9, and the right hand side is 10, 11, 12 we have here now. This is I give also here, which we will not consider any example concerning with the homogeneous system, because we will not, as I told you, we will only consider the non-homogeneous system. That means right hand side is not equal to 0. Of course, if your system right is homogeneous system mean the right hand side is 0. That we call, but we not consider this one in our case. Now, as I told you, how to say our system is, how I say the system is linear. You know the linear mean all equation. System mean more than one equation given at a time here. Linear mean all equation must be the linear one, the power 1. Simultaneous mean number of equation and number of variables should be 1. Non-homogeneous mean the right hand side is not equal to 0. And non-singular mean the determinant is not equal to 0, or the the given matrix, coefficient matrix A is invertible. That means this is the most important job we have to do in chapter number 3 to play with the A matrix. Here we have to check A is singular or non-singular, invertible or not. You remember that one, to find the determinant is, or to find the inverse of a matrix is a difficult job in the matrix theory. It's not easy. Yeah? Okay, it is easy if you are playing with a matrix size 2 by 2, 3 by 3, let's say 4 by 4. But if we have a matrix size 10 by 10, 20 by 20, 1 million by 1 million, of course, to find the determinant is not an easy job to do. So here what we do, we will not find the singular system or non-singular system with the help of directly determinant. I will give you the shortcut. And that shortcut will be, inshallah, help you. Doesn't care about the size of the matrix. What size of the matrix you have, he doesn't care about it. That's what we will do, inshallah. And after that one, also I give you one condition. You only look on the system and inshallah you can say my system is singular or non-singular. And that condition I give you. But we step by step here now, okay? After that, I give properties of the matrices and the determinant. I will not discuss this one. You already have this is the basic idea, okay? We know how to deal with the matrices or equal matrix or addition of the matrix, multiplication. You already know this one, no need to discuss here now. This is the main things we have to discuss. That is called some special matrices we have here now. And the special matrices that will help us to give the shortcut of the idea to find system is a singular or non-singular. So, of course, what is your matrix in chapter number 3? Your matrix in chapter number 3 is mainly the matrix in chapter number 3 is this one here. And what is your A matrix? What is the size of A matrix, please?
N cross N.
Yes, the size. It's mean you are solving the shortcut to find the non-singular idea, or you find the determinant, or you'll find the inverse. What is the first condition you should have? Your A must be a square matrix. And the square matrix mean the number of row and the number of column must be equal. We have here. So this is the things I give you here now. In the special matrices case we have now, whatever matrix, special matrix I give you, it must satisfy this condition. Square matrix. And square matrix will approach us or take us to the idea of the non-singular idea here. And square matrix is what? When A equal to Aij, with I represent row, J represent column, and they must be the same. Then we call that matrix is a square matrix here. And this is, I give you the definition, sorry, example of that square matrix here, where A is 2 by 2, B is 3 by 3. So these are the square matrix. But one thing, remember that one. As I say, every square matrix is invertible. No, this is not true. But to find invertible, it should be the square. If your matrix is square matrix, maybe invertible, maybe not. Maybe determinant 0 or maybe not equal to 0. But if go reverse way, if the determinant is not 0, guarantee your A should be a square matrix. That we will discuss, inshallah. The more special matrices on next time here. This is, we will not use too much here, but simple idea I give here. Null matrix. Null matrix means zero matrix. Zero matrix mean all the possible element of that matrix are 0. like this one is a 0 by 0 or 0 by 0. Right? Any question, please? Next time we start from here again, some special matrices. And then this will give us a shortcut to approach to the non-singular system idea that we will use throughout our case, inshallah, in chapter number 3. Any question, please? No question? Say yes or no, please. Don't be quiet here.
Yes.
Is
Yes.
okay? Is okay now? Good.
Yes, it's clear.
Yes, it's clear.
So inshallah, we will continue next time from here special matrices. And very quick again, we are dealing with a linear system. We are dealing with a simultaneous system. We are dealing with a non-homogeneous system. We are dealing with the non-singular. Why? Because we want to approach to the unique solution of the linear system. We continue, inshallah, more about this one next time here. I take your attendance.